A warm welcome to the fourth film in our Flat Roofs series, in which we explain how flat roofs are constructed. In structural terms, the construction of a flat roof is very similar to the construction of a floor or ceiling. Though the environmental loads are slightly different, the transfer of loads in a flat roof is basically the same as in a floor. Horizontal forces generate longitudinal compression and tension loads, vertical transverse forces cause shear at bearing points, and vertical forces at the span center result in bending forces that in turn create compression and tension forces within the component involved. The various possible types of flat roof construction, depending on the materials used, are therefore the same as those for floors. The most common are solid reinforced concrete slabs, beam-type reinforced concrete floors, steel girder floors with corrugated steel sheeting, and wooden joist floors. Like floors, they all have one thing in common: the principal compression and tension forces occur at the upper and lower edges of the structure. We have already established that a flat roof forms a collecting basin that needs to be surrounded by a projecting upstand or parapet wall to prevent water from running down the facade of the building. According to Germany's flat roof regulations, the horizontal waterproof membrane must come at least 15 centimeters up the side of the upstand to prevent the ingress of standing water into the wall. It is this requirement that determines the height of the upstand. A flat roof is generally located above a heated room and must therefore also be insulated against heat loss. The insulating material is usually placed on the outside of the roof slab. If standard rectangular insulation panels were used, then the flat roof would not have the necessary 2% slope. This problem is solved by the use of tapered roofing insulation. These insulating panels have a tapered section and are produced on a bespoke basis for individual roof slopes. The shape of the insulating panels required depends on the position of the roof drain, which should be located at the lowest point of the roof. If the drain is sited in the center of the roof and the insulating layer slopes outwards at an angle of at least 2%, then the highest point of the roof lies at the upstand. In the opposite case, water is removed externally via a downpipe, as for a pitched roof, rather than internally through the building. Here, the lowest point of the roof is at the upstand and its highest point in the center of the roof span. The upstand needed in this case is lower than that required for a central rainwater outlet and internal drainage. Irrespective of the position of the rainwater outlet, a secondary drainage system is required in case the rainwater outlet becomes blocked. Known as an emergency drain or emergency overflow, it can be sited at the highest point of the roof, as it will only be called into action if the normal drain fails. Emergency overflows are often designed as waterspouts, as they provide a clear indication that there is a problem with the main drainage system. As an alternative to tapered insulation, it's also possible to construct the entire roof surface with a slope. This removes the need for costly, bespoke tapered insulation, but means that the underside of the roof will also slope slightly and so alter the appearance of the room below. Imagine a large picture hanging on a wall in such a room. The line where the wall and ceiling meet would not be parallel to the top of the frame. Summary. The construction of a flat roof is very similar to the construction of a floor and can be achieved using a solid or a beam-type design. A projecting upstand is required to prevent water from running down the facade of the building. The horizontal waterproof membrane must come at least 15 centimeters up the side of the upstand to prevent the ingress of standing water into the wall. Insulation on the outside of the roof plate minimizes the loss of heat through the roof and can be used to set the required slope of at least 2%. Why not take a look at the fifth film in our Flat Roofs series? In it, we discuss the various layers that make up a flat roof.